So the next thing we're going to talk about is this section right here. So 1.2, rates of change. We're going to talk about something called a secant and a tangent, okay? So the kind of topics for this particular lesson include rates of change using a formula. We're going to learn about a secant and a tangent, and then we're going to find the slope of the tangent using a specific formula. Okay, so those are just the topics that we're going to cover in this particular lesson. So rates of change. So for any function, there are two rates of change. There's an average rate of change and an instantaneous rate of change. So we can kind of talk a little bit more about what each one of those means. An average rate of change is the rate of change, so how quickly or how slowly something is changing between 2 points in time. Okay, so if you're driving on the road, you can calculate your average speed by picking any 2 points at which you were driving and calculating the average. Instantaneous, do you guys know what instantaneous means? Do you guys know what that word means? This word right here, instantaneous. Have you heard that before? Exactly, great, yeah. So at a certain point in time, at one point in time, you want to know what the rate of change is, okay? So average rate of change is over an interval, and then instantaneous rate of change is at a certain point in time. So rate of change, so there's a formula to find the rate of change that I will give to you guys, okay? So let me write it in here, and give me 1 second just to pull it up here. So the average rate of change is the change in speed over your change in position over change in time, okay? So for average rate of change, the change in position over change in time. So how far you've moved divided by how much time has passed. For instantaneous rate of change, it's a little bit different. I'll maybe write it out for you guys. So that's one of the formulas that we use for the instantaneous rate of change. So these letters are all arbitrary right now, but what we're going to do on the next slide is I'll kind of draw a diagram and I'll kind of explain what A is, what H is. And then we'll talk about what a secant is and what a tangent is, okay? So I'll draw like a little graph just to illustrate this. So a secant is a line drawn through 2 points on the curve, okay? The secant relates to average rate of change. Yes, I can, yep. So that screen. Okay, just let me know, Fan, when you want me to move forward, okay? Once you've written that down. Okay. Okay, so a secant relates to the rate of change specifically for the average rate of change, okay? So if you hear the word secant, it's talking about the average rate of change, and that's because it's between 2 points on the curve. Okay, so 2 points in time, and you want to find the average between them. So secant relates to the average rate of change. And let me just kind of draw in just a rough sketch so you guys can get an idea of what a secant looks like, okay? So maybe I'll just change my size of font, but okay, so I can just make any graph here. Okay, so this is a sketch of a graph. This green graph right here is on the XY axis. A secant, oh, okay, so Miko, sorry, you're asking about like the slope of a line? Is that what you're asking about? That's how we would find the secant, if that's what you mean. That's how we would find the slope of the secant. Yep, exactly. Yep, y2 minus y1 over x2 minus x1. That's exactly how you find the slope of a secant. Let me draw the secant in, and then I can maybe mention that or talk about that, okay? Let me just draw the secant in a different color. I'll draw it in yellow. And the secant is a line, so it's a straight line drawn through any 2 points on the curve. So you just pick 2 points. Maybe I'll want to find that point to that point right there. So the secant is this yellow line drawn in here. That's the secant right there. We call it secant, S-E-C. That's the secant. It's a line drawn through any 2 points on the curve. And as Miko mentioned, what tells us the average rate of change is the slope of the secant. Okay, so the slope of the secant, so the slope of the line, the slope of any straight line is just what Miko said. It's m. M usually represents slope. So m equals y2 minus y1 all over x2 minus x1. So to find the slope of the secant, it's the slope of a line, so y2 minus y1 over x2 minus x1. Yeah, Fan, for the most part. Sorry, I'm just reading the chat bar right now. For the most part, yeah, it's called a curve if it's not a line. You might hear different words for it. It could be parabola, it could be the cubic function, but a curve is a good way to describe a graph that's not a line. But yes, yeah, for the most part, it's called a curve. So if I ask you to find the average rate of change, what you're doing is basically finding the slope of that line. So that's for average rate of change. A tangent is something that's a little bit different, and a tangent relates to the instantaneous rate of change. Okay, so the tangent is used to find the IROC, the instantaneous rate of change. So the tangent is a line drawn through 1 point on the curve, 1 point because it's looking for instantaneous rate of change, which happens at 1 moment in time. So a tangent is a line drawn through 1 point on the curve and follows the direction of the curve, okay? So give me a second and I'll draw another graph in. So I'm just sketching a parabola, and I'm going to draw a tangent at a certain point. So I'm going to draw a tangent at this particular point in time here. I'm going to draw a straight line, which should work. Okay. So the red line is right here, this red line. Oops, I'll do that. The red line is the tangent. Tangent to the curve, you can say. So the red line is called a tangent line, and it is What it represents is the instantaneous rate of change at a particular point in time. The particular moment in time or point in time is where it crosses the curve. Okay, so where it touches the curve. There's a specific formula that we're going to use to kind of illustrate how we find the instantaneous rate of change. Okay. Fan, are you doing okay? We're kind of entering and leaving, but I think you should be back in now. Okay. So like I mentioned that there's a particular formula that we would use to find the tangent. And it's basically built off of finding an average rate of change. So what I'm going to do is I'm going to leave the slideshow for a minute, and I'm just going to enable the whiteboard to kind of illustrate where the formula comes from before we start to use it, okay? So give me a minute, and I'm going to draw another graph, and okay, so we have a